All right, so this is how you will work the this matching vertical, this matching activity. All right, so this is in Schoology. This is the worksheet that you have. Also in Schoology is this page that you don't have. Okay, so what I want you to do is number these graphs. I'm gonna take a picture of this and I'm gonna number it. I'm gonna number it as 1, 2, 3, 4, 5. And I'm gonna make this 6, 7, 8, 9, 10. Okay, so you're just gonna number the graph like that. Okay, so what we're gonna do is match the equation with the correct graph. So how are we gonna do that? Well, that means that we have to graph the equation. So how are we gonna graph the equation? We go to the desmods.com. I told y'all in class, told y'all about in class. So if you go to, let me add a new page, www.desmods.com, and it just says start graphing. And we have our graphing calculator. So we just type in the first graph is y equals x squared plus 3. And I'll just hit the y and the equal sign. X, got the square button, then plus 3. And then we hit the little blue return button. So this is my graph of that function. So some things you need to notice is crossing at the y-axis at 3. So we see that point is on there. All right, some other points that are on there. Looks like we have this point. Trying to click on it. It's not quite it. Uh, if you just ride along right there, looks like. So you could pick points on there. I'm trying to do it on my iPad, but I'm having problems. Uh, if you if you click if you click the function and click the little spin wheel up there on the function, you can look at the table and look at values for your points. So like we can access the table on the calculator, which I'll make sure that you can do in class, but these are the table values. So now I'm looking for that graph on this worksheet here. So if I look, I see two parabolas or two quadratic functions. Uh, so going back to where we had numbered it, let me go to my photos. And there we go. And to the ones that I had numbered, we go here. We go. So if I look, it's out of 7 and 10. So remember, we're looking for the one where it's crossing the y-axis at 3. So that looks like it's at 7. That's number 7. So in the graph box, we would put the number 7, like so. Okay. So now in the box, in the middle box, it says parent function and transformation. It says then type the parent function and the transformation to the correct graph and equation. So it says type, but this is, you should really, what we're going to do is write the parent function, the equation of the parent function. So what Mr. B also put inside the folder, in the Schoology folder, let me go back to Schoology, and it's in the folder that's labeled today's date, 11/06/2019. I put a parent functions matching, the parent function equation and graph. So if you click on that and it opens up, whenever it's going to open up, it has a picture of each parent function. Some of these we're not using, but it has the equation as well. And so you see the quadratic parent function, the one that looks like the U-shaped graph, the parabola. So that parent function is f of x equal x squared, or we could simply just say y equals x squared. Let me edit this. Go to three dots, mark up. So we know is y equals x squared. So not only do they want the function, but they also want to know, well, what is the transformation? What happened if I was to graph my parent function? How do I go from my parent function to the new equation? So this is where we go back to Desmos, okay, and we're going to add a function. Uh, so we have, I erased it, but we have y equal x squared plus 3. That was the related function, and our parent function was y equal x squared. So the question is, how do I go from the parent function, which is the y equal x squared, this blue function here on the video, to the black function, which is the relative function, y equal x squared plus 3. So what does it look like? Well, it look like they just moved the graph of x squared up 3 units. Every point on this graph went up 3 units. 1, 2, 3. So now instead of being at 0, 0, we're at 0, 3. All right. And if I look at the table of each one, so if I open up, let me go back to the page here. If I click on the table for this one and click on the table for this one, you see that the x squared is at the bottom. Or the x squared table is at the bottom. We have all of the y values, all of the x values are the same. -2, -1, 0, 1, 2 on our table. But the y values are different. For -2, let me do it in red. For the x squared function, we had 4, but for the x squared plus 3 function, we had 7. So that's a change of 3. And each time, each one of these is a change of 3. So what does that mean? For our transformation, we're going to put, you can put moved up 3, moved up 3, let me put the number 3, 3, units. Okay. So I'm going to do, I guess I'll do like 3 more, and then I'll do 2 more in class. Well, no, I'll do 2 more here, and then I'll do 2 more in class. So let me skip to look at the worksheet. I want to look at number 8. Look at number 8. So we have y equal 1/3 to the x power plus 5. So we want to graph it first. So I'm going to go ahead and take these off. And we have y equal x, no, 1, so there's a fraction. We'll put parentheses, 1, divided by 3, close parentheses. Need to close it out of here. And we're going to raise it to the x power. So you see that a to the b little button right there? That allows us to raise to a certain power other than squared. So I'm going to raise it to the x power. And we got to get from by that x. So press the right arrow key. Then plus, I believe it was plus 5. If I'm not mistaken, let me look again. Yes. Okay. So what graph is that? Well, I see that it's this kind of this curve down, and we see that it's crossing at 0, 6 on the y-axis. So I need that graph. So the only ones that kind of look like that curve down, and let me go and look at the picture. Ah, done. Done. Okay. Yeah, done. There we go. So the curve down look like it's 2, 5, like it's 2 and 5. 8 is a curve like that too, but it's shaped a different way, or it's open in a different way. So it's out of 2 and 5. The only one that's crossing at 6 or positive is the 2. So it looks like 2 is my graph. All right, so let's go back to the word. I'll take a picture of this. And we know that 2 is the graph. Now they want to know the parent function. So these are exponential functions. And if I go to the one where we pulled up the table, I'm sorry, the pictures of all of the parent functions, okay, we see that, of course, this is going to give me some problems, so let me download this, download. It's going to let me open, I don't know. View, okay, I'm going to just view. All right, so the curve that we're looking at, right here, the exponential. We have a couple of these that have like a curve, but if you look at the ones that curve like that, does it look like the equation that we have? So you have to be careful with all of that. See, with this one, you have the a to the x, where a is some number to the x power. We have another curve with this one, which is the logarithmic function, but you see the function says log a of x, so I don't see that as a part of my equation. So all these other curves do not have the a to the x in it, where a is just some number. So we know this is the exponential function. So if I go to Desmos, which was the, okay, where was I? Right here. So the a in this case is the number where I'm raising it to the x power. So that's the, in this case, is just 1/3. A is 1/3, so it'll be y equals parentheses 1 divided by 3. We're going to close the parentheses and do the a to the b power. I'm going to raise it to the x and hit enter. All right. So those are my two functions. Let me change the color on this second one. So you could change the color instead of go to let's see. Let me change it. Supposed to be where you could change the color. Let's see. I doubt it. There we go. So you hit the little spin wheel. Let me go. Let me do this. You click on the function and you hit the spin wheel and you hit that color. So if I want to make it blue, I make it blue, and then now you can see which one is which. So the blue function is my parent function. The red function is the relative function. So notice that the on the blue function, my y-intercept was 0, 1. On my red function, the y-intercept is 0, 6. So not only that, if I open up the table for each one, we see that the x values didn't change. And the original function, my parent function, had a 9 when x was -2. But on my relative function, it had a 14 when x was -2. So what's the change right there? If I add 5 to 9, I'll get 14. Same thing at x equal -1. I went from 3 from the parent function to 8 on the relative function. 3 plus 5 is 8. Even for the rest of them, even those decimals, when x was 1, you have 0.33333, right? But when x is 1 for the relative function, you have 5.33333. So in each case, we're adding 5. So it moved up all of those points. And if you look on the graph, those points are highlighted. And we see that each one of those points moved up 5 points. I thought I took a picture. Where are you? There you go. So we're going to edit that. And we said that the parent function was, I got to pick the markup. There we go. Said the parent function was y equals 1/3 to the x, and the transformation is moved up 5 units. Okay. Let's look at a linear one. Let's look at number 6. So when I look at number 6, we're going to graph it. So I'm done with these. Let me X those out. I got y equals, what it was, negative 2x plus 1, negative 2x plus 1. All right. So we see that this is a line graph. On this line is crossing the y-axis is 0, 1, crossing the x-axis at 0.50. We got some other points on here. You can find different points. Even go to the table. We'll get some points there. All right. So I'm looking for a line. This has a negative slope. It's crossing through the y-axis at 1 and crossing through the x-axis at 0.5. So we're going to look at our picture. Get done on this. Get done there. Oh, this iPad be giving me the blues. Where's the picture? There we go. About time. So I see the only lines I see are graphs 1, 6, and 9. So 1, 6, and 9. 9 is the only one that has a negative slope. And, well, no, I'm sorry. It's 1, 6, 3, and 9. 3 and 9 are the only ones that have a negative slope. But number 3 is where it's crossing the y-axis at 1. So therefore, my answer on my graph for number 6 is 3. Edit that, mark up. I'm going to put a 3. All right. So now what is the parent function? Of course, we know this is linear. This is really easy. We know about linear functions. The parent function is f of x equal x, or just y equal x. If I was to graph that function, let's graph the function y equal x. All right. So we see it's a couple of different transformations that happen here. Okay, let me revert back to this. Oh, my bad. The X back and hit enter. Let's go back to man. Trying to go back to the function. Like the actual function. Bring it back. Okay. Maybe I need to hit this again. Okay, so I'm clearly have some issues with dealing with Desmos. So let's just go ahead and look at the table for the Uh, so if I look here, it looks as if the x values did not change, right? But look at this. When x is 5, when x is -2 for my parent function, the y value is -2 for the parent function. But on the transformed or the relative function is 5. So one might say, oh, well, it went up 7. It's going to let me write. It's going to let me write. Hey. So one might say, okay, that's a change of 7. But if I was to look at the next one, -1 and 3, that's not a change of 7. That's a change of 4. So there's not a constant change. So it's not just a move up or anything like that. So what do we think that is? I don't know right now. Now, Mr. B knows. This is just, in this case, there are two transformations. Transformations. And we're going to talk more about multiple transformations. Okay? So for right now, what Mr. B wants you to do for the ones that have multiple transformations, he wants you to just identify the graph and identify the parent function. And we'll talk about the multiple transformations. So for number 6, we know is y equals x is the parent function. And we'll talk more about the multiple transformations. So 5 is a multiple transformation. 7 is a multiple transformation. Let me see. Number, and I think that's the only ones on this page. Let me look at the first page. For the first page, number 2 is a multiple transformation. Let me put that. That's a multiple transformation. And number 4 is a multiple transformation. So all the rest of the ones that are not multiple transformations, I'm looking for for you to identify the transformation. All right, and the parent function. The ones that are multiple, just give me the parent function. And for all of them, give me the graph that go with it. All right, hope this helps.